Okay, next topic is mean free path. Between two successive collisions, the path traversed by a molecule will be straight line, as we have seen in last lecture. Between two successive collisions, molecules always travel in a straight line with constant or uniform velocity. But at each collision, the direction of path changes. The path of the molecules is shown in this figure, that is figure 1.1, figure free path of the molecules. That is, the molecule is moving in one direction in straight line. After collision with one molecule, it again changes direction, again travel with the straight line. After again colliding with another molecule, it again changes its direction and travel in a straight line, and so on. That is, hence the path of the single molecule consists of the series of short zigzag path. The distance traveled by molecule between its two successive collisions is called a free path. The free paths are not of the same length, and hence the term mean free path is defined. Now consider there are n numbers of successive collisions of a single molecule, and suppose lambda 1, lambda 2, lambda 3 and so on to lambda n are the length of free paths during n successive collision of a single molecule. Therefore, the mean free path can be expressed as lambda equal to, take the mean of all those successive collisions, the free paths of all successive collisions, that is lambda 1 plus lambda 2 plus lambda 3 and so on to plus lambda n upon total number of collisions, that is capital N. That is, this can also be expressed as total distance traversed by a molecule in n collisions, that is total distance upon number of collisions, that is S upon n. Thus, the mean free path can be defined as the average distance traveled by a molecule between two successive collisions. That is, the average distance traveled by a molecule between two successive collisions is the mean free path. The mean free path of a gas is of great importance in studying transport phenomena such as viscosity, conduction of heat and diffusion. This is very important line. The mean free path of gas is of great importance in studying transport phenomena such as viscosity, conduction of heat and diffusion. Now, how to calculate mean free path? For this, consider, in order to specify the calculation, let us assume that only one molecule which is under consideration is moving while the remaining are at rest. For this, for the calculation mean free path, we are considering here only one molecule is moving and other are at rest. Now, suppose let small n be the number of molecules per unit volume of the gas, and sigma be the diameter of each molecule, and v be the velocity of moving molecule under consideration. In figure, we can see that molecule is moving in right direction with velocity v, and sigma is the diameter of molecule, that is diameter of molecule, and n be the number of molecules per unit volume we are considering here. Now, the moving molecule will collide with all the molecules whose center lie within the distance sigma. आता या डिस्टन्स सिग्मामध्ये, याच्या डायमीटरच्या त्या सिग्माच्या डिस्टन्समध्ये, म्हणजे डायमीटरच्या डिस्टन्समध्ये जर कोणते मॉलिक्यूल्स येत असतील त्याच्या ट्रॅव्हलिंगमध्ये, तर त्या ठिकाणी काय होणार, त्या मॉलिक्यूलचं कोलायडिंग होणार त्या दुसऱ्या मॉलिक्यूलसोबत. दॅट इज द मुव्हिंग मॉलिक्यूल विल कोलाइड विथ ऑल द मॉलिक्यूल्स whose center lie within the distance sigma from its center. In 1 second, the molecule will travel a distance v, and hence it will collide with all the molecules whose center lie in cylinder of radius sigma and length v. Obviously, v is the velocity of the that single molecule in forward direction. Therefore, in 1 second, it means that in 1 second it will travel distance x. It will travel distance v. Okay, it will travel distance v. Now, the volume of the cylinder is, obviously, the volume of the cylinder is, we here the diameter diameter of molecule is sigma. Therefore, त्या सिग्माच्या रेंजमध्ये येणारे सगळे मॉलिक्यूल्स, म्हणजे या ठिकाणी त्या सिलेंडरचं डायमीटर होऊन जाणार टॉईस सिग्मा, ज्याप्रमाणे फिगरमध्ये दाखवलं आहे त्याप्रमाणे. अँड वी नो दॅट हियर द रेडियस ऑफ द सिलेंडर विल बी ओनली सिग्मा. देअरफॉर द व्हॉल्यूम ऑफ द सिलेंडर विल बी pi into radius square. What is radius here? Sigma. That is pi sigma square into length of the cylinder, that is height of the cylinder. That is here v is the length of the cylinder, that is height of the cylinder. Okay, here therefore the volume of the cylinder is pi sigma square v. The number of molecules contained in this cylinder is pi sigma square v n, where n is the total number of molecules. ठीक आहे, here n is the number of molecules per unit volume of the gas, जे आपल्याला वरती सांगितलेलं आहे, per unit volume of the gas. ठीक आहे, त्याला फक्त त्या नंबर ऑफ मॉलिक्युल्सने जर मल्टिप्लाय केलं तर आपल्याला मिळते नंबर ऑफ मॉलिक्युल्स कंटेन इन दिस सिलेंडर, या सिलेंडरमध्ये असणारे मॉलिक्युल्स. सो द नंबर ऑफ कोलिजन मेड बाय द मुव्हिंग मॉलिक्युल इन 1 सेकंड, आणि तो तेवढेच त्या ठिकाणी काय करणार, कोलिजन करणार. देअरफॉर द नंबर ऑफ मॉलिक्युल्स, नंबर ऑफ कोलिजन्स मेड बाय मुव्हिंग मॉलिक्युल इन 1 सेकंड इज पाय सिग्मा स्क्वेअर VN. As the distance traveled in 1 second is V, the mean free path will be. Mean free path is, we have the definition of mean free path, lambda equal to distance traveled in 1 second about number of collisions in 1 second. ठीक आहे, जितके डिस्टन्स ट्रॅव्हल केलं ते, जसं आपण मीन फ्री पाथच्या डेफिनेशनमध्ये बघितलं तेच आहे या ठिकाणी, डिस्टन्स ट्रॅव्हल इन 1 सेकंड अपॉन नंबर ऑफ कोलिजन्स इन 1 सेकंड. देअरफॉर हियर डिस्टन्स ट्रॅव्हल इन 1 सेकंड that is small v upon number of collisions in 1 second is pi sigma square VN. Here VV gets cancelled, we get lambda equal to 1 upon pi square n. Pi square n. Now the expression for lambda is based on the assumption that the molecule collide with other stationary molecules, which is not the actual case. Maxwell considered the general case when all the molecules are moving with different velocities in different direction and applied distribution law, which gives the expression for mean free path. आता मॅक्सवेलनं काय केलं, आता या ठिकाणी जेव्हा आपण मीन फ्री पाथचं एक्सप्रेशन काढलं तर हे मीन फ्री पाथचं एक्सप्रेशन फाइंड आउट केलं, लॅम्बडा इक्वल टू 1 अपॉन पाय सिग्मा स्क्वेअर n, विच इज ऑन द बेस्ड ऑन द ॲझम्पशन दॅट वी हॅड ॲझ्युम दॅट इन स्टार्टिंग ओनली वन मॉलिक्यूल विच इज अंडर कन्सिडरेशन इज मुव्हिंग व्हाईल रिमेनिंग आर ॲट रेस्ट. बट इन ॲक्च्युअल प्रॅक्टिस other molecules are also in motion with different direction with different velocities. Therefore Maxwell considered the general case when all the molecules are moving with different velocities in different direction and applied the distribution law which gives the expression for mean free path. मॅक्सवेलने त्याची मीन फ्री पाथ फाइंड आउट केली सगळं कन्सिडरेशन करून, लॅम्बडा इक्वल टू 1 अपॉन अंडर रूट ऑफ 2 n पाय सिग्मा स्क्वेअर. Here lambda is the inversely proportional to the square of the molecular diameter. That is, here we can see here lambda is inversely proportional to the square of the molecular diameter. Now mean free path in terms of pressure and temperature. We know that the pressure of the gas is given by P equal to nKT. nKT, there K is the Boltzmann constant, T is the absolute temperature. Now P equal to nKT, therefore n equal to P upon KT. Hence the mean free path lambda equal to, या ठिकाणी फक्त काय केलं आहे, लॅम्बडाची व्हॅल्यू KT अपॉन अंडर रूट ऑफ यांची व्हॅल्यू फक्त पुटअप केली वरच्या इक्वेशनमध्ये, यांची व्हॅल्यू पुटअप केल्यानंतर आपल्याला मिळते लॅम्बडा इक्वल टू KT अपॉन अंडर रूट ऑफ टॉईस पाय सिग्मा स्क्वेअर P. Thus the mean free path varies directly as the absolute temperature and inversely as the pressure. From this equation we can say that is mean free path is directly proportional to the absolute temperature and inversely proportional to the pressure. Mean free path in terms of density of gas. Now suppose if m is the mass of the molecule and n is the number of molecules per unit volume, then the density obviously equal to mass upon volume. What is the mass? M into capital N, small m, this is the mass of one molecule, and n is the total number of molecules. Therefore that will represent the total mass. M into n represents the total mass of the gas upon volume of the gas. Therefore the density of the gas will be equal to m n upon v. Now here rho equal to m n. आता या ठिकाणी n काय घेतलेला आहे, n equal to n upon v, small n equal to capital N upon v. Therefore rho equal to m n. Therefore we have n equal to rho upon m. Therefore as the mean free path of the gas, mean free path expression आपल्याकडे आहे lambda equal to 1 upon under root of 2 pi sigma square n, and by substituting the value of n in this equation we get lambda equal to m upon under root of pi sigma square rho. That is, we can see here that lambda is inversely proportional to the density of the gas. Lambda is inversely proportional to the density of the gas. Now next topic is here transport phenomena. Now in this transport, okay, we will see in this next lecture.